Hello everyone and welcome to today's video. We're actually going to be going over how to get the nth item from Fibonacci sequence. In order to do that, we need to use the theorem, the golden ratio to the n minus the negative inverse of the golden ratio to the n all over radical 5. But Java really doesn't have the golden ratio as a math constant, so we have to make that ourselves. So what we're going to do in this situation is we're actually going to call in or get a double, because we're going to have to kind of rationalize this. We're going to have to get somewhat close. We're not going to get the exact number, but we're going to get somewhere close because we can't get the exact number. Get nth Fibonacci item into n, and what this is going to do is this is going to get double golden equals golden n, and double inverse golden equals 1 over golden n. So what this is going to need to do is that we're going to have a private golden n, which equals, or the method is going to return a double, and the body to this is if n equals 0, then we return 1. Else we return 1, 0 plus 1.0 divided by golden n minus 1. And this is actually going to be an integer, so that's how that works. And what we need to return here is return math.pow of golden to the n minus math.pow of inverse golden to the n divided by I think I'm missing, yep, divided by math dot I'm forgetting how to do the square root of a power. Oh, well, I could just do, it's just the square root of 5. And that should return us the nth number of the Fibonacci sequence. If I save, then I have no error. So we go to our application, and I'm going to say enter an integer, and this is going to call not that, but instead, I don't like how my IntelliSense is not really picking everything up. So get nth Fibonacci item. And if we do that, if I get the 5th item, it should be, I think, 5. And it's pretty close. It's 5.027. So if I make this an integer, so if I take this and I wrap this around as a new integer and do .toString of it, so this returns a double. So what I can do is just typecast it to an int. And that's not how we typecast in Java. So many languages have so many different ways to typecast, but that's how we typecast. So if we do it again, so let's say 5, I get 5 back. Now I know the 15th item of this is going to be 610, But since we're not actually getting the perfect golden ratio constant, we're not going to be able to get the exact answer. We're going to get an approximation. So if I type in 15, I should get approximately 610. I get 610 exactly if I cast it to an int, but if I don't cast it to an integer, then I should get some approximation that is pretty close to 610 that we can just consider it 610. So get the 15th item, we get 610.00194. That is close enough to being 610 itself that we just consider it 610. So that's how we do. And that's how we actually get the nth item of the Fibonacci sequence. I'm going to look up really quickly nth item Fibonacci and see how close we are to this answer. I'm going to get, so I bring this over, we can see that f of 20 is 6,765. If I do that, then I should get approximately that number. So I type in 20, I get 6,764.999. So if I typecast this, I should get 6764. When you typecast, you don't round it. When you typecast, you just truncate the decimal places. Therefore, everything just falls off at the decimal places. So I should get 6764, and I do. But if I keep the decimal places, it is so close to 6765 that we can really consider this to be 6765. So that is the end of this. I'm actually going to go through the code and how I did it. So what I did is I created an entry point that we're going to enter the program at. This is a public method, meaning this is an entry point into the program itself. So this is a point in which that I can call in. I'm going to pass in an integer, and what I'm doing is I'm getting the golden ratio of the of number n, or the nth golden ratio, which is nothing more than a recursive value of returning 1 plus 1 divided by n minus 1, recursively calling this. Basically meaning that once we keep going all the way to the end, there is going to be some point that this basically, if we go to infinity, this should cut off at some point. This is a limiting integral. This is going to end. This has a limit, therefore we will get that limit, and once we do get that limit, that's what we care about. And we return that as our technical golden ratio. Then we do the same thing, but we put it 1 over it to get the inverse. And an inverse of a number is just 1 over that number. Then we minus it and take it to the nth power with the mat.pow class, and then we take the square root of 5. This line 40 is nothing more than we're returning the expression that is going to solve the for the number that we desire. And that's all this language does. That's all this program does. It's a very, very simple thing. As long as you can break down a very tough equation into its small little tiny things and build out those small little tiny things in a programming language, you're golden. Hopefully you got that pun. Now, thank you all very much for watching. I will see you guys next time in the next video. Thank you very much.